ambiguous case, having side-side angle, which y'all know, if you flip that around, that is not the conditions that you need for similarity. But that has nothing to do with the law of sines, just reminding you of that. There are certain situations with this that multiple triangles could exist, and we'll look at that here in a second. But this first case, very simple. Only one triangle is possible. So let's jump into solving this. We know that little a, side A is 22 inches, side B is 12 inches, and angle A is 42 degrees. We want to find the remaining sides and angles. Well, up to this point, when we've been solving the entire triangle, it's been very easy to find the first piece of information because we've had 2 out of the 3 angles. The easiest thing to do is find that third angle. We only have one angle here, so we can't start with that. We're going to have to start with finding the missing angle. We're going to have to start with finding angle B. So let's do that. Let's set up the law of sines with what we know. Sine of angle A, sine of 42 degrees over 22 is equal to the sine of angle B over 12. Okay, we're still going to cross multiply and divide. So we've got 12 sine of 42 degrees is equal to 22 sine of big B. So then we divide by 22. But this time, that number right there is not the answer. Okay, the number that we get, thank you, ma'am. Make sure we are in degree mode. That number, 12 sine of 42, close parentheses, divided by 22, is not the answer. That doesn't really make sense. That 0.365 would be our angle B. What is that actually equal to? The sine of the angle. So how do we solve for the angle? Can we divide by sine? Is sine a number? No. Inverse. Okay, we're going to do the inverse sine. That will give us the angle B. So I suggest don't round it. Do inverse sine second negative. Okay, inverse sine second negative. That will give you the most accurate answer. It's still going to be an approximation, but it will be more accurate. 21.406 degrees. Now we know 2 sides and 2 angles. We need to find the third side and the third angle that are corresponding to one another. So let's set up the law of sines again, reminding you that I always like to use the given information. I'm going to go back and I'm going to use sine of 42 degrees over 22. I'm not going to use the sine of 21.4 over 12 in case I made a mistake in that 21.4. Okay. Now, the question is, we know we definitely don't have side C. So that must mean that we can figure out angle C. How can we figure out angle C now? Subtract from 180. We got 2 out of the 3 angles at this point. So 180 minus our answer minus 42. So that other angle is 116.593 degrees. I'm going to try and keep that in my calculator so I don't have to estimate. So cross multiply 22 sine of 116.593 is equal to the sine of 42 degrees. C's in front of that. And then we divide both sides by the sine of 42. So 22 sine of the answer, close the parentheses, divided by the sine of 42. That does give us C, 29.4 inches, because they gave us units in the beginning of the problem. So we've got C there. This is angle C. I didn't label it. I'm just going to box it up there, and there's angle B. Those were all the missing parts. Remember what I told you to do. When you've got to solve these triangles, go back and check make sure that the smallest angle is across from the smallest side. So our smallest side was 12. Is angle B our smallest angle? Yes, it is. 21 versus 42 on 116. Okay, the biggest angle should be across from the biggest side. The biggest angle is 116, the biggest side is 29.4. Those are both C. And A fits right in between those two. Okay, always check that. Okay, here's what I want you, or well, no, I'm going to show you this, okay? Next example, we are going to show that there is no triangle for which side A can equal 15, side B can equal 25, and angle A is equal to 85. So we're going to jump into trying to solve it, okay, but apparently it's not solvable. Let's find out why. I'm going to flip over the law of sines, again, just to emphasize that it doesn't matter whether the side is on top or whether the angle's on top, just so you're consistent. You're going to end up with the same answer, I promise. If it bothers you, you can do it the other way, but I just want you to recognize it. Okay, so 15 over the sine of 85 is equal to 25 over the sine of B. Cross multiply, 15 sine B equals 25 sine 85. Divide by 15. So sine of B equals, or is approximately, let's find that number in our calculator, 25 sine, not cosine, sine 85 divided by 15 equals 1.66. Okay? So our next step was to do the inverse, right? Inverse sine of that. Look what happens. We get an error. It says the error is with the domain. What's the problem with that right there? Sine of B is equal to 1.66. It's bigger than 1. Sine and cosine can never be bigger than 1. Okay, sine of B cannot be greater than 1. Okay, sine of B cannot be greater than 1, so we're stuck. I mean, that's the only piece of information that we could find at this point, and if sine can't be greater than 1, okay, this triangle is not possible. Okay, it is not possible to build a triangle with those side lengths and that angle in those positions. Okay, now if that angle were between those sides, let's draw the triangle really quickly. Okay, let's set up the triangle. We've got A, B, C. So if this is 85 degrees, I know that doesn't look very much like 85 degrees. This is 15 and this is 25. Apparently, it's not possible with that angle measurement and those side lengths. Something's not going to match up. Something's not going to meet. It's not going to form a complete triangle. What I was saying was, if the 85 were perhaps this angle between the 15 and the 25, it may form a triangle. Okay, it may form a triangle. I don't know. I'm not getting into that. I just want to throw that point out there. Okay? But with the way that it's set up in this position, you cannot form a triangle. Okay? All right, so